What's up, guys? We're talking about functions. Let's get right into it. So a function is an operation that takes an input and gives an output. So you might be wondering, like, what does that even mean? What is an input and what is an output? But let's go ahead and start with an example. So let's say that I have a function that looks like this. F of x equals x. So this right here is going to be our input, and this f of x is going to be our output, okay? So if I plug in x equals 1, I will get y equals 1, because remember, f of x is equal to y. So that's going to have the notation f of 1 equals 1. What I'm saying is that for my function f of x equals x, if I plug in x equals 1, I'm going to get 1. So that's what that means, right? This just shows I'm plugging in x equals 1. Now let's do another example. F of x equals 2x. If I plug in x equals 1, I will get y equals 2. So this is going to have the notation f of 1 equals 2. If I have the function f of x equals x squared and I plug in x equals 2, I get y equals 4. And that is going to have the notation f of 2 equals 4. So hopefully that makes sense. If I say x equals 2, then I'm really just saying f of 2, right? And if I want to figure out what f of 2 is equal to, I'll just plug in x equals 2 here, and I'll get 2 squared, so therefore f of 2 equals 4. So hopefully that makes sense. Okay, so here's our first example. Given f of x equals 4x plus 16, what is f of 4? Okay, so our first question is, what is the x value? Now remember, guys, I said that anytime you have f of x and you have this little value here for x, that tells us that x equals 4, okay? So the x value is going to be x equals 4. Now it's asking us, what is the y value? So remember, guys, this whole thing right here is the y value, but we want to figure out what it is numerically. So if I have f of 4, that's going to be me plugging in x equals 4. So I'll have 4 times 4 plus 16. I will therefore have f of 4 equals 16 plus 16, and therefore f of 4 equals 32. So if f of 4 equals 32, that means that y also equals 32, okay? So hopefully that makes sense. Okay, so why do we care about functions? We care about functions because they can accurately describe real-world phenomena, okay? So things like waves, things like forces or gravity, right? We can kind of express these real-world phenomena through functions, okay? Now, how do I know if something is considered a function? Now, sometimes this will come up on standardized exams, but basically in order for a function to be considered a function, for our cases, right, it must obey 2 rules. First of all, for every input, there must be only one output, okay? So if I have, let's say, f of 1, right, this is only going to equal one value, okay? So this is only going to equal one value. It's not going to equal multiple values, okay? If it equaled multiple values, that would not be a function in our case. Now, the other thing is it must obey something called the vertical line test. And what this means is that for every x value we input, there must only be one y value, okay? So for example, okay, if I have a graph here, right, and I have a parabola that looks something like this, well, the vertical line test would basically just be, you know, me kind of taking this vertical line and going back and forth. And as long as there's only one point that touches this vertical line at a time, then it's a function. Now, if it looks something like this, if I had a parabola that was facing like that, and I took my vertical line and I drove it that way, what would happen is eventually I would hit 2 points at once. So I would have a point here and I would have a point here. And what that means is that I now have 2 y values for one x value. And that would not be a function, okay? So for our cases, right, this is not a function. So just something to keep in mind. Okay, so what is a root? A lot of times you'll see a question like this on a standardized exam, and you just have to remember that a root is basically the x-intercept of a graph, okay? So if I have a function, and let's say it's doing all sorts of weird stuff, right? Looks kind of like that, super weird. A root is going to be any time that this function crosses the x-axis right here, okay? So, or it could even just touch the x-axis, okay? So this is a root right here where I'm circling. That's a root, that's a root, that's a root. This is not a root because it does not cross the x-axis. This is a root and this is a root. So anytime y equals 0, the corresponding x value is going to be our root, okay? So root. The root is the x value. Okay, so hopefully that makes sense. Now, what is a composite function? Now, a lot of times you'll see something that looks like this, and it can be kind of scary. Like, what the heck is going on here? I have like a function inside of a function, kind of like a Russian doll. So basically, a composite function is quite literally just a function inside of a function. For example, if f of x equals 3x and g of x equals 2x plus 1, then f of g of x is going to be equal to 3 times 2x plus 1. So let's go ahead and write out what I did here. if I have that f of x equals 3x and g of x equals 2x plus 1, I'm just going to take my function here, and I'm going to plug in g of x for x. So if g of x is 2x plus 1, I'm just going to say, okay, well, what is f of 2x plus 1? And remember, whatever this is right here, I'm just going to plug in for x. So plug in for x. Now, if it's initially equal to 3x, I'm just going to take 3 and then plug in this entire thing for x. So I'm going to have 3 times 2x plus 1, and that is how you do that, okay? So if I have x equal to 1, then all I'm going to do is just plug in x equals 1 here, okay? And where I'm going to get 9. So basically what you do is, first of all, you can just kind of figure out what g of x is equal to and then plug it in for the x in the composite function. So hopefully that makes sense, but we're going to do some more examples to really make sure it's ironed out. Okay, so given the composite function f of x equals square root of x and g of x equals 1 over x squared, show that for all values of x, f of g of x has to equal 1 over x. Okay, guys, so yeah, actually just ignore this part. I just want you to show that f of g of x equals 1 over x, okay? Now, basically, how we can do this is let's just go ahead and apply what we learned before. So f of x equals the square root of x, right? Now, I want f of g of x, right? So I need to plug in g of x for x. So I'll do f of g of x equals the square root of g of x. Now, what is g of x? Well, g of x is 1 over x squared, so I'm just going to plug that in for g of x. So I'm going to have f of g of x, and that is going to be equal to the square root of 1 over x squared, so I'll take the square root. Now, guys, we'll have to use some exponent rules, okay? So I threw in a little bonus review. So we're going to have the square root of 1 over the square root of x squared, and we are going to end up with 1 over x. So there you go, guys. That checks out. Okay, we made it to the challenge problem, so let's get right into it. For the composite function z, and remember, guys, these 3 bars here, that just means defined as. So for the composite function z is defined as f of g of h of x, and f of x equals g of x equals h of x equals e to the x. Compute the value of the natural log of the natural log of z given x equals the natural log of 1, and your hint is what does z equal? So go ahead and try this problem on your own, and if you get it right, great. If not, I'm going to go ahead and explain how to do it right now. So this problem might look a little bit daunting at first, and I designed it like to look like that on purpose because I really want to kind of challenge you guys and stretch your thinking so you really get to down to the foundational concepts. So let's go ahead and start out by how we should solve this. So I gave you the hint, what does z equal? So the first thing that I want to do here is I want to figure out what is the function of z? How can we simplify z? So z is, again, defined as f of g of h of x. So let's go ahead and just write that out. So if z equals f of g of h of x, first of all, I want to figure out, well, what is h of x? Well, we know that all these functions are actually the same, and therefore h of x equals e to the x, okay? So let's go ahead and rewrite this. I now have z equals f of g of e to the x. Okay, guys, so now I want to know what is g as a function of e to the x. So I'm going to say, all right, well, if g of x equals e to the x and g of e to the x, or x is equal to e to the x, now what is this equal to? So I'm actually going to have e to the x because I have to plug in e to the x for x here, right? So I'm going to get this kind of weird double exponent, okay? So now let's go ahead and simplify it further. So I have z equals f of e to the x, okay? So now that I have this, I want to figure out, okay, well, what is f of x? And I know that f of x is also e to the x. So I need to figure out what is the value of x. Well, our value of x is e to the x. So I have f of e to the x, and that is going to equal e to the e to the x. So now it looks really weird, right? Now don't be alarmed because this is totally solvable, okay? So now that we have our final value here, let's go ahead and rewrite our function, the function z. So whenever I rewrite it, now it's going to look very interesting. Z is now equal to e to the x. Now, that's great. Now we know what z equals, but I want to know what is the natural log of z, okay? So now we're going to do some logarithm rules, and if you don't remember those, check out the last video I made. Okay, so let's go ahead and get right into it. So what I'm going to do is I'm going to take, well, okay, so we have z equals e to the x, right? Now I want the natural log of z, right? And I wonder, what does that equal? Now I'm just going to plug in e to the x for z, okay? So I'm going to have natural log of e to the x, okay? So now that I have all this, I'm going to have to use some logarithm rules, okay? So remember, anytime that I have an exponent to an exponent, I can rewrite that as a product of the exponents. Okay, so let me show you what I mean. So I'm going to have the natural log of the natural log of e to the e times e to the x. Okay, so I can rewrite this as a product of the two exponents. Okay, so now what I want to do is I want to simplify this further by using the exponent rule for logarithms. So I remember that the natural log of this whole mess here is going to be the same thing as the natural log of e times e to the x of the natural log of e. Okay, so hopefully you remember that from one of the last videos, but if not, you can feel free to check that out. So now that I have this, well, the natural log of e, this is just going to be 1, right? So now I have the natural log of e times e to the x, and that is going to be equal, well, it'll be multiplied by 1, but again, it's just 1, so I'm just going to leave it like that. So now I have this expression here. So because we have e times e to the x, and we have the same base, which is e, I'm going to rewrite this as the natural log of e to the x plus 1. Okay, so now that I have that, let's go ahead and simplify it even further. Again, I can take this exponent out and use that kind of exponent product rule here. So I'm going to have x plus 1 multiplied by the natural log of e. Now guys, again, remember the natural log of e is just going to be 1. So now I have this entire thing equals x plus 1. And now guys, if x equals natural log of 1, I'm kind of running out of room, but let's see, I'll go ahead and clear some space over here. So if I have that x equals natural log of 1, then I'm going to have the natural log of 1 plus 1. And we know that the natural log of 1, well, that's just going to be 0. So I'm left with the natural log of the natural log of z equals 1. And that is our final answer, guys. Okay, so if you have any questions, feel free to comment below. And yeah, also if you like and subscribe, that would greatly help me out. But yeah, if you have any questions, always feel free to comment below, and I will see you in that next video.